Hello everybody, this is Mr. Kusaj, and we're up to chapter 3-4, exponential and logarithmic equations. So we talked about both of these in terms of graphs and evaluating, but now we want to look at equations, right? Find x, that type of thing. Don't forget the date up here. So first of all, let's look at a property or a rule. It's called the one-to-one property, and what that means is if you can get the bases, right? If you can get the bases to be equal, then you can claim that the exponents are equal, right? So it's kind of like, if you look, then this happens. If this happens, then this happens. It's kind of like the bases go away. You can ignore the bases and just say this is equal to this. But that only happens if the bases are equal. If they're not equal, then you can't do that, right? So for example, 3 to the x equals 3 to the 5th. Well, that means that x must equal 5. But that only works because you have equal bases or the same bases. So your job will be to, if the bases are not equal, to make the bases equal. So let's look at the first example. So what do we have here? We have 36, right, to this power, 6 to this power, right? So can we say x plus 1 equals x plus 6? No, we can't say that right now because the bases are not the same. But if you look closely, I can change this 36 to a base 6, right? Because we know 36 is really 6 squared. So now, if you look, the bases match. Now you can drop the bases and say this is equal to this, right? Well, before I drop the bases, you got to know it's this times this, right? So it's 2 times x, 2 times 1. It's not 2x plus 1. It's this whole thing multiplied, and you get this. Now you can drop the bases, and now you have just a regular equation. Combine whenever you can, so minus x, minus 2, etc., and you get the answer. Okay? So we're looking for same bases. Look at the next example. Right? Obviously the bases are different. But did you know that 64 is a multiple of 2? So you notice a 2 in here, so you start thinking, well, I got a 2 here, and is 64 a multiple of 2? Well, yes, it is. If you didn't know that, then you would check. 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th. You just keep going to see what power of 2 is equal to 64. But before we get to that, this is really a denominator 2. Now, do you remember the rule that you can change the denominator to a numerator or flip it? In other words, you can flip it if you change the sign of the exponent, right? So a 2 on the bottom, power x, is the same as 2 on top, negative power x, right? So I got the 2 here. Here, one way or another, I found out that 64 is really 2 to the 6th power. Okay, you have to find that out. How did I know that 64 is 2 to the 6th? I knew, but if I didn't know, I would just keep trying. 2 to the 3rd, nope. 2 to the 4th, nope. 2 to the 5th, nope, till you find it. So now I have same basis. Now I can claim this equals to this, right? But first, right, write it negative x is equal to 6 times a half. And 6 times a half is 3, so x must be equal to negative 3. Right? 6 half is 3, and negative x is 3, so x is negative 3. Okay? So the point of this is, or the goal of this is to first make bases the same, right? And then you can sort of drop them, ignore them, and work with the exponents as an equation. Okay? So same thing for, well, same rule for logs. If you have the same little number right here if you have the same base, right? You're working with logs now, but the idea is the same. If you can make log with the same base on both sides, then you can ignore that and just say this is equal to this. Okay, so obviously if you don't have that, you got to make that. So here's an example. So, oh, good. The bases are the same, but I need to condense this because my rule says log. I see the term log once here, once here. Here I see it twice, so I need to combine this. So we use the properties, right? What does plus mean? It means that it's log of this times this, right? So this gets condensed, right? If you remember the last assignment. So now I look and they're both log 4, so I can ignore the log 4 part and make my equation. X equals this whole thing, right? Etc. I put etc. here because I think now we know how to solve it. Okay. Another one. Oh, this is easy, right? Because you're set to go. So why is this here? It's so easy. Well, it's easy, but once you get the equation, your equation might be a quadratic. Look, my equation has an x squared in it, right? So you got to know how to solve those. So first, I do minus 3 on both sides. So I get x squared. And then I square root both sides. And remember, it's plus minus, so you get positive 7, negative 7. So for this one, we get 2 answers, but we knew we would get 2 answers because straight on the top here, straight from the beginning, we saw an x squared. Okay? So it was easy to start, but this one, you had to remember that there's 2 answers. Okay. For natural logs, where am I? Right here. For natural logs, you're going to use e to cancel it, right? We mentioned this in the last assignment. Whenever you see e and ln together, they cancel. For common log, you're going to use 10 to cancel it. Remember, there's like an invisible 10 here. This is common log, so it's understood that it's base 10. Okay? So how do you use the e and the 10 to cancel those things? Watch. Let's do the ln first. So solve this equation. It says ln x equals 6. Right? So how do you solve that? Divide by ln? No, that's ridiculous. Right? So we need to cancel the ln, and the way that we cancel the ln is to raise both of these, right, to a power for e, right, ln x 6. But I put an e on both of them, and now, why did you do that? Because the e and the ln cancel. So I'm left with x is equal to e to the 6, and you hit the calculator, and it'll give you an answer. E to the 6 has an actual answer, right? Look at this other one. So first, we need to isolate the log, and then we'll cancel it. Right here, the ln was already isolated, so right away I went with the e. Here, we're going to use a 10 to cancel this, but we're not there yet. We got to isolate the log 5x. So cancel the 6, right? Cancel the 2, divide both sides by 2, and now you have log 5x of 6, equals 6, I mean. So this is common log. This is different from the other problem, right? This is common log. So if I only had a 10 right here, with this little 10, I could cancel it. So put your own 10 in there, right? Make these powers of 10. Why'd you do that? Well, since this is base 10 and this 10 is here, these bases, right, it allows you to cancel this whole thing here. So you're left with 5x. So 5x equals 10 to the 6. Well, nothing cancels here. So what? This is just calculator work, right? We're not canceling both sides. Yeah, usually when you do equations, you're used to canceling on both sides. Here, whenever you get, getting back to here, whenever you get e and ln together like that, they cancel. It doesn't have to be on both sides. Here, whenever you have 10 to the common log, it cancels. It doesn't mean you're going to do it, you do it to the power 10 on both sides, but it doesn't mean you have to have a log on the other side. It doesn't mean you have to have an ln on the other side. Okay? So you're just canceling here. Anyway, 10 to the 6 is 1,000,000, divide by 5, etc. Right? Okay. So what we learned here was that the ln can be canceled with an e, and the common log can be canceled with a 10. Okay. Now, when we're doing exponentials again, what if you cannot find the same base, right? What if you can't find the same base? For example, right, going back to the beginning, suppose you had, this is an example, I'll give you the official examples in a second, but here's what I'm talking about. 2 to the x equals 8, and you say, oh yeah, that's 2 to the third. So 2 to the x is equal to 2 to the third, so you say, oh, that's easy, x equals to the third. But that worked because you were able to change this 8 to a base 2, right? That's why that worked. What if we started like this? Now what? Right? There's no way to change that to a base 2. So what do you do now? Well, we have a solution for that too. You're gonna use log or ln, either one. If you remember a property from the other section, it allowed us, one of the properties allowed us to bring the power down to the front, right? So if I take log of both sides, just put log here and log here, right? If I do that, nothing cancels, must see. You're right, nothing cancels. But now I can use a property to bring the x down to here, right? And now I have x log 4 equals log 13. And now these are just values, right? These are just numbers I can get in the calculator. So I'm looking for x, so divide both sides by log 4, right? In your calculator, that cancels, so in your calculator, log 13 divided by log 4, and you got the answer. So what this rule, I call it trick, what this rule does is it allows you to bring the x, which is an exponent now, it allows you to bring it down and treat it like a regular factor, a regular number, in a regular position. Right? Shall we do it again? Okay. E to the 4 minus 3x equals 6. How would you do this? Well, if you take ln of both sides, look what we have. This cancels. So now we're left with 4 minus 3x equals ln 6. Remember, this is just some number. Minus 4, right? On the calculator, and then divide by 3 on the calculator, and you're done. So again, we used ln on both sides to cancel this e, and we were left with ln 6 on the other side. Okay? What is this? This is, so sometimes when you get your equation, you're going to get quadratics. Okay, you really have to feel comfortable with quadratics by now. So look at this example. So I have ln, so I know e cancels ln, but I can't do it to both sides because I have 2 on one side, right? So I'm going to combine these, right? So the property says that it's ln of this times this. There it is. Now think about it. What's going to happen here? Right? Eventually we're going to multiply these and get an x squared. Right? So you can drop the ln, right? You can drop the ln because they both have ln. So this equals this, but this has to be multiplied out, right? X times 3x is 3x squared, etc. Right? And now combine, bring everything to one side. So you get this equation, right? Change the signs. You're allowed to change the sign. You will multiply through by a negative. And now you can use the formula or try to factor it. First try to factor it, see if you can. If you can't factor it, then use the formula, the quadratic formula. Can I factor? Yes, I can. So it comes out to x equals 2. X equals 2, but it's the same answer, so the answer is 2. So here I was just trying to show you that sometimes the first step is easy, but then you end up with a quadratic that involves many more steps. Okay? That's it. And by the way, this is part 1 and part 2. I'll put that on the label. But here are some try problems for you to try at home, and then we'll finish them in school when I see you. So that's A and B. So all we're doing is solving, right? C and D. And one more. I put a star next to this one and a hint. So good luck with that. So next time I see you, we'll start the class with these 5 try problems. Okay, it's like almost 17 minutes, but it is part 1 and 2, so it comes out the same. All right, see you in class. Bye.